7, page 180, is where you should be. And we're going to look at group A. If I look at group A, what form is group A in? What's this one? You could call it standard. You could also call this one vertex form. Because if I write it like this, the reason I can say that it's also in vertex form is if I write it like this. There's a 1 that would be in front of the parenthesis. X minus 0 squared. Does everybody understand that? If I take x minus 0, what is it still? X. And then what would be x squared? Would just be x squared. And then what could I put back here? Now, why did I do it like that? Because now I know what is my vertex. My vertex is 0, comma, negative 4. And if I look on here, doesn't that match up with what is on the graph then? Could this also be in standard form? Yes. So this is a tricky one. You could call that either vertex or standard, depending on how you look at it. It was really easy for me to take it from standard to vertex because there was no middle term. If there's a middle term, it's not as easy to do. When I'm talking about middle term, does everybody see this one right here? What form is this one? This one is in standard. This is not in vertex because I've got this term right here. What are some of the things that you know about this? So does everybody understand how I found the vertex here? So if I know the vertex is here, and which way was this facing? So if I know the vertex is down here, and I know it's facing up, don't I know that it's going to intersect twice before I even graph it? Are you with me on this? Okay, this is how we're talking, like thinking through. So let's look at this one right here. What does standard form give me? The y what? Gives me the y-intercept. What is the y-intercept? The y-axis, but what is it? Where is c at? There is no c back here. So how could I write that in there? Plus what? 0. So what do I know my y-intercept is? And what's my x when I'm on my y-intercept? So it's 0, 0 is going to be that coordinate. If you look, isn't that true on here? Now, I also know that this graph is facing down, right? Could I find the vertex? Could I find the vertex? How do I find the vertex? Opposite of b over 2a. Opposite of b is 6 over 2 times a what? Negative 1. Because that's a negative right there. And I would get negative 3. Does that match up with what my graph says? 1, 2, 3. But it's up here. How would I find the y? Because that's just the x coordinate. How do I find the y? Plug it in. Negative 3 squared is... Be careful on this. Let's do this one. This is a perfect example of where we can make a mistake. When I plug this in, be careful on this. Negative 3 squared is what? 9. But what's out here? So it actually puts it back to a negative 9. Are you with me on that? And then what happens when I have a negative 6 and a negative 3? What does that become? Plus 18. And when I subtract, I say negative 9 plus 18, what do I get? And so what's my order pair? Negative 3, 9. And doesn't that match up with what my vertex is right there? Yes, ma'am. Because there was a negative right here. And actually, so this brings us to a great point. This is actually read as not negative x squared. It's actually read as the opposite of x squared. Because what you do is, like if I put the number 3 in here, 3 squared is what? And then I take the opposite, so it would actually be a negative 9 also. Okay? So you have to be careful on this one, because there's a difference. There's a difference between this and this. And this one, your answer will always be positive, because you're going to take the negative number and square it. Well, negative and negative is always going to make a positive. So whenever you put any number in here, and if you even put a negative 3 in here, be careful on this. You'd put a negative, but you'd have a double negative, so it'd make it a. But positive 3 squared would still become positive. So every answer in this problem would become positive. Whereas in this example, every one of these would be negative. Because you square first, then you take the negative sign. It's like this. Really, this is written as a negative 1 times x squared. And think of order of operations. Which one do you do first? You do exponents first, then you multiply. So that's why that's very tricky. Because what do a lot of kids want to do? They want to put, like if I said put a 3 in here, they'd make it negative 3 squared, and they put 9, which is the wrong answer. It should be a negative 9. Okay? So that, I get, that's the part of math that's very, very tricky. Because these look very similar. Two separate answers. Alright, so let's go back to this group A. Do we see how, if this is up here, and I have the y-intercept is down here, I know that it's going to intersect over here. Don't I know there's going to be how many intercepts again? 2. Are you with me on how I can figure this stuff out? I'm reviewing a lot of the section 1 through 4. Right here, group B. How many times does this intersect? Once. Because the X-intercept is what? The vertex. How could you figure that out? What would you do? What form is this in? Standard form. How do you find the vertex in standard? We just did it. Opposite of B over 2a. Opposite of B is 6 over 2 times a negative 1. Again, it ended up being a negative 3. That's my what coordinate? Negative 3 is my what? How do I find my y? Negative 3 squared is going to be 9. But you have the opposite of that, so it's a negative 9. Negative 3 times a positive negative 6 is a positive 18. And minus 9. Sorry. So negative 9 plus 18 would be what? Positive 9. 9 minus 9 would be? Isn't that what we thought was going to happen? Yeah. And doesn't that back up what we thought? Yeah. Looking at the graph. Okay, same thing here. Let's do B, just because we need some practice on some of this stuff. Opposite of B is going to be what? You have that on your paper, so if you can't see it up here, opposite of B is going to be what? 4, just the 4, we don't bring the x, over 2 times what? 1/2. 2 times 1/2 is 1, and 4 over 1 is just, so I've got 4 as my x. How do I find my y? What do I do? And 4 squared is 16. Half of 16 is 4 times 4 is, so we have 8 minus 16 plus 8. Well, 8 minus 16 is negative 8. Negative 8 plus 8 is 0. Doesn't that back up what we thought was going to happen? Again, my vertex is falling on my X-intercept. And which way do I know this graph is facing? Up. Which way is this one facing? So I know kind of which way this is going to be going. Are you with me on this? If we did the same things for these, we'd realize that the vertex, you'd find the vertex here, for this one, opposite of b over 2a, you find that it's here, you know that it's facing up, which means it's never going to touch this x-intercept. So we're going to talk a little bit, we started this yesterday, about what that means. All right. A couple ways that we can solve for this. So the other day, yesterday, I talked to you a little bit about this quadratic equation. Quadratic equation, if you remember, was opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, what will this only work? What form is the only one that you can use this from? You can only use this from standard form. Because standard form is the only one that has my A, my B, and my C. Are you with me? Well, if we look, they gave it to us all in standard. But I just want to make sure that's clear before you guys start trying to do this with factored form or vertex form. All right. This quadratic equation will find the roots. It will find the x-intercepts. This guy right here will find the x-intercepts. So here's what I do. Let's write A. What is A in this one? It's not x. It's the number in front of it. It's the one in front of the x squared. It's 1. Remember, it does not include the variable. Remember, it's a x squared, so just the number, plus bx, just the number in front of the x, and plus c. Okay? So what is my b here? Be careful. I got different answers. I got -4 and I got 0. Which one is it? It's 0. Because look, I could rewrite this as x squared plus, what if I need to write an x in there? What would I need to write in front of it so there's none of them? Right? Because what's 0 times x? Nothing, right? So it's like it's not there, but now I can write it like that. Does everybody see if I write it like that? Now I see my b is 0, my a is 1, so this is 0. What is my c? Good so far? All right. So we go and plug this into the quadratic equation. Plug this into the quadratic equation. Opposite of b, what's that going to be? You could write that in there. Plus or minus square root of 0 squared minus 4 times 1 times what? That's huge that you don't forget that that's a -4. All divided by 2 times what? So let's simplify this. Zero plus or minus the square root of 0. What happens when you do -4 times 1? -4. -4 times a -4 is a positive 16. All divided by 2. Zero plus or minus square root of 16 divided by 2. 0 plus or minus, what's the square root of 16? 4 divided by 2. Now, when I go to do this part, I've got to separate it. One time I'm going to have 0 plus 4 divided by 2. And the other time I'm going to have 0 what? Minus 4 divided by 2. What is this answer going to be? 0 plus 4 is 4. 4 divided by 2 is 0 minus 4 is a -4. -4 divided by 2 is a -2. So this told me that my two x-intercepts should have been 2, 0, and negative 2, 0. Notice, are these two an ordered pair together? No, they're two separate ordered pairs. And if I go back to my graph that they gave us, doesn't that check out that it's right there at positive 2 and at negative 2? So we got positive 2 is one of them, and negative 2. And didn't our quadratic equation find that out for us? Okay. The quadratic equation, you can do that for the rest of these. And what you're going to notice is you're going to see this pattern. We're going to skip down to this section right here. Page 182. This is going to be one of the big parts for us. The part that is underneath the square root, notice, looks like this. It's b squared minus 4ac. Does everybody see what I'm talking about? That is called the discriminant, because it discriminates the number and the type of roots your quadratic is going to have. Does everybody understand that this is underneath the square root? Okay, so let's talk about this right here. Let's talk about, you don't have to write this here, you can write it wherever you want. What happened when I have a square root of a positive number? Do you remember in front of it I had a what? What was in front of the discriminant? A plus or a minus. What happens if I have a positive number under the square root? I'm going to get two answers. Right? Because one time I'm going to add whatever that is. One time I'm going to subtract whatever that is. So I'm going to get two answers, and they're both going to be real numbers. What else could happen? What's another scenario where I have b squared minus 4ac? What else could happen? Not just a positive number. What else could I get? Okay, we'll go there. What if I have a plus or a minus, and I have a square root of a negative? What did we just spend the last two sections learning about when you have a negative under a square root? So you're going to have two roots, but they're going to be what? Two imaginary roots. What's another case? There's one more case. What else could happen to b squared minus 4ac? Doesn't happen very often, but it could happen. What happens when you subtract two numbers? They could be positive, they could be negative, or they could be what? 0. What happens if you subtract those numbers together and it comes to a 0? What happens if you add 0 to a number? It says, what if you subtract 0 from that same number? So how many different answers are you going to have if you add or subtract 0? You're only going to have one real root, because you're adding 0 to it. You with me? So what I can do in these types of problems, do you see right here, they gave you the graphs. Under my discriminant, which is that b squared minus 4ac, what do I know my number is going to be, because it has two real numbers? Each one of these has two real roots. What do I know my discriminant underneath that square root is going to be? Positive. How many roots do I have here? 1. What do I know is going to be underneath my discriminant? 0. How many real roots here? None. What do I know is going to happen underneath my discriminant? It's going to be a negative. So here's what I'm saying. If you took these numbers right here, let's take this one right here. If I did b squared minus 4ac, what is that known as? It's known as the discriminant. You better start learning these words. It's known as the discriminant. If I take this and it's positive, what do I know? Two real roots. If it's 0, what do I know? one real root, and it also has what's called a multiplicity, or it's called a double root. It means that this real root happens twice. We'll talk a lot about that more later on, but just understand it's a double root. It's the same number twice, but you only graph it once. And then if you have a negative underneath it, we know that it's going to have what? Two imaginary. What does this really mean? Two X-intercepts. What does this mean? One X-intercept. And what does this mean? Zero X-intercepts. And I should say, because we only graph real numbers. Are you following along with me? So if you wanted to figure out how many X-intercepts this problem has, all you have to do is go b squared minus 4ac. B squared is, what is b for this? Let's label them. A is what? 2. B is negative 12. Be careful on that. It's a negative 12. And C is what? Everybody with me so far? B squared. Now notice, remember how from middle school they asked you whenever you plugged in, what are you supposed to use? Back in middle school, your teacher should have told you, whenever you plug in, you always use parentheses. Here's the reason why. In middle school, you're like, that's so stupid, I don't understand why. Here's the reason why. We learned today, is there a difference between this, Sarah? Is there a difference between this and this? And so if I don't plug in using my parentheses, I should, if I do this problem correct, get a negative 144, which would be wrong. If I plug in using my parentheses like I've been told to, I should plug in, and this is actually negative 12 squared, which is a positive 144. Are you with me on these little things? Minus 4 times 2 times 19. Someone have a calculator? Actually, here's what we can do. You want to see how we do something really quick? Mental math. Do you see how 8 times 19? I don't like that math. Do you? But I do like 8 times 20. I can do that in my head really quick. Because 8 times 2 is 16. And throw a 0 on the end, so it's 160. Are you with me? So 8 times 20 would equal 160. But I don't have 20, I only have 19 eighths. So I can just take away an 8 and I get that it's 152. That's called mental math. Does that make sense? So I know that it's going to be 152. Here's my next question. See how smart you are. Do I really care what 144 minus 152 is? No. All I care for my question is, I care whether it's positive, whether it's 0, or whether it's negative. What is this answer going to be? Negative. What does that mean for this problem? I have 2 imaginary roots, which means 0 X-intercepts. Are you with me? If I go back and I look, this was group C, the first one. Go back up to group C and look at the first one. How many X-intercepts did it have? 0. Does that match up with what I just found out? Because my 2 roots should be imaginary, because underneath my square root, I'm going to have a negative. And we just learned the whole last 2 sections where if you have a negative under a square root, it's an imaginary number. Yes? All right. So for homework, it's going to ask you to do this. To say imaginary, so use any method to determine as real or imaginary zeros. It says you don't need to calculate what they are, just need to say how many are there. Are there 1, 2, or no X-intercepts is basically what it's asking. Remember, roots are X-intercepts. So for homework, you're going to do A, B, and C so far. Does that make sense? Alright, I told you this the other day. Fundamental theorem of algebra, which we're going to use, states that any polynomial equation of degree n must have exactly n complex roots or solution. Also, every polynomial function of degree n must have exactly n complex zeros. However, any root or zero may be a multiple. So basically, here's all it says. If I have x to the fifth, how many roots do I know I'm going to have? 5. And it's going to be, it can be a combination of real or imaginary. We're going to talk about imaginary roots. They actually have to come in pairs. So right here, what are my possibilities? I could have, I have to have 2 imaginary. I could have 2 imaginary. And then what else would I have? 3 reals. Does that make sense? I could have 4 imaginary and what? 1 real. Am I allowed to have 3 imaginary? Why? What did I say they have to come in? They're actually called the conjugate pairs. They come together. So you couldn't have a 3. What else could you have though? Could you have 6? How many is the most that you can have? If you have x to the fifth, the most amount of roots you can have together is 5. Do you see how 2 plus 3 is? 5. 1 plus 4 is? 5. What's the other option I could have? Can reals come, do they have to come in pairs? No. No, so could I have 5 just straight up reals? And how many imaginaries would I have in that? And we'll talk more about that in the later sections. But that's what this fundamental theorem of algebra is discussing. Okay? So this is why, do you remember when we talked about how you have, it said you're allowed to have multiple roots? Do you remember when I had, when it's the square root of 0 for my quadratics? That's x squared, right? Are you with me? Yeah. How many roots does this have to have? Has to have 2. So what happens when I have that square root of 0 is I have 1 real root, but it has a multiplicity of 2. It means it happens twice. Remember how I said it's called a double root? And like I said, we're going to talk a lot more about this in other sections, but just to give you a preview of it. Does that kind of make sense to you? So it says, explain why it's impossible for a quadratic equation to have 2 equal imaginary solutions or a double imaginary. Because what did I say? Imaginaries have to come in what? Pairs. Conjugate pairs. So that means that if I have 3 plus I, 5i, what do I know the other root has to be? 3 minus 5i. Has to come in its conjugate pair. So could I have this root happening twice? No, because how many would that mean I'd have to have? I'd have to have more than just 2 roots. Week 1, brother. Alright. So this is probably a question that could be like a test question. Circle the functions that could describe the given graph. Explain your reasons. What do you know about this graph right here? Facing down. So what can I get rid of right away? So does everybody understand why I can get rid of that one? Now, what else could I check? I could check there's not supposed to be any x-intercepts. How can I figure out the x-intercepts for these guys? What did we say? What do I know is going to happen with my discriminant? Since there's no x-intercepts, what do I know my discriminant would have to be? Right, which means my discriminant is going to be what? Negative. So I could come down here and go b squared minus 4ac and check which ones are going to be negative. If I put negative opposite of b, or b squared minus 4ac, and I figure out this is positive, what do I know? Can't be this one. Are you following me? If I check this one and it's negative, could it be a solution for this? Yes. What else could I check to see if this is good? Because this is, again, test question. I need to figure out everything. Let's say Mr. Martin said there's only one solution for this. Let's say this one is a negative discriminant and this one is a negative discriminant. What could I next check to see if it matches up with this graph? Chapter 1, or section 1. I could check its vertex. Do you remember? What do I know about the vertex of this right here? Okay, but what do I know about the x? Since it's to the right, so the vertex is to the right, what do I know about the x? It's positive. What do I know about the y? It's negative. So could I figure out its vertex and see if it matches up with what's happening there? Are you following me? So I want you to try that question. I've only done a couple of them. I want you to try this one. Hold on, I'm going to have you try this one for homework. Try this one for homework too. I'll do one with you real quick. If I say it's you stay after, you can stay after. Try number 1. I guess I'll let you go. Go ahead and see if you can get these done. This is problem 2, 1, and it looks like it's page 185. You should be able to do it with what I've given you. Use the hints of the characteristics.